In Math 1 and Math 2, we talked about end behavior. We didn't have as formal of a language as we're going to use in Math 3, but we did talk about it. Did the graph go up forever? Did it go down forever? Where did it go as x increased or decreased? In Math 3, we're putting a formal notation to that, and we're saying as x goes to infinity and as x goes to negative infinity. So, as x goes to infinity in our first function, we can see as x gets bigger and bigger and bigger, my y value gets smaller and smaller and smaller. So as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, so as my x's get more and more negative, my y's, my f of x's actually get more and more positive. So my f of x goes to positive infinity. Second example. In our second example, as x goes to positive infinity, so as x gets bigger and bigger, my graph continues to go up. So my f of x also goes to positive infinity. As x goes to negative infinity, in this case, my graph is continuing to go up. I have some dips in here, but the end behavior is that my y's get bigger and bigger. So the f of x is going to also go to positive infinity. Example 3. Example 3 looks an awful lot like example 1 in terms of that the end behavior is going in the opposite direction. One is going up, one is going down. So as x goes to positive infinity, as x gets bigger and bigger and bigger, my y's get bigger and bigger and bigger. So f of x goes to positive infinity. As x goes to negative infinity, in this case, as x gets more and more negative, my y's also get more and more negative. So these are 3 examples that when you're given a graph, you can visually see what's happening at the extremes as x gets really big and as x goes really negative. The other kind of examples that you'll be doing will be ones in which they give you an equation. And so now you have to have a sense of what these look like. For my purposes, I think the easiest thing for me to do is just to do a quick sketch. And so I can see that this is a cubic function, which means it either has this shape or this shape, one or the other in general. And so now my job here is to kind of look at these x's. So if I do x times x times x, that's going to be an x cubed. And if I multiply these, it's positive. And when I multiply it by a positive 4, it's also positive. So the graph looks like this picture. So as x goes to infinity, f of x also goes to infinity, and as x goes to negative infinity, f of x also goes to negative infinity. Positive, positive direction, negative, negative direction. You should recognize this one as an exponential function. Our exponential functions kind of have this business. And exponential functions are really interesting because as x goes to positive infinity, we can see here that we're going to get bigger and bigger and bigger. So f of x gets closer and closer to positive infinity. However, as x goes to negative infinity, we actually are getting closer and closer to a particular value in this case. We are getting closer and closer to f of x being 0. Now, we're never going to get there. Dividing by 5 over and over again is going to get us a really small number, but never 0. And so that's why we say it approaches it, it gets close to it. Now, logarithmic functions is something that you have been playing with quite a bit in class, and you'll have experience with the fact that the logarithmic function is going to have this general shape. And so as we're looking at these values, as x goes to infinity, f of x continues to get bigger. It does continue to get higher up. It just is a slower process than when we're looking at the exponential. So f of x also goes to infinity. And as x goes to, oh, this one's kind of tricky because we can never actually put in negative numbers. So it actually turns out that in this case, as x goes to 0, f of x is going to go to negative infinity, which we can see there's a nice relationship between our exponential function and a logarithmic function here, which should make some sense given the fact that these are inverses of each other. There's an inverse relationship there. For our square root function, we end up with this kind of shape. And so as x goes to infinity, oh, I'm sorry, I actually used different letters here. Excuse me, this should say g of x and g of x, and this should say h of x. So we've got g of x here and g of x here, and here we have h of x is also going to go to infinity. It gets bigger and bigger and bigger, more slowly than an exponential, but it does. But in this case, we have a bottom. We actually have a minimum point here of 0, 0. So we don't really have a place where we can say, well, as x gets more negative, it's smaller. It doesn't. It stops at 0. So we can actually say here, and this may depend very much on what your teacher has been telling you, so you'll want to check in with them. But I would say that we can't talk about x going to negative infinity. Instead, we can actually say that when x equals 0, h of x equals 0. There's actually a minimum here. We can't go any lower than x being 0 by the rules of taking square roots of negative numbers.